So let's discuss what happens when you have a mixture of acids. Well, the approach is going to be similar, but it does depend a little bit on if you have a strong or a weak acid that you're combining, or two weak acids. But in general, the takeaway rule from mixtures of acids that I hope that I'll repeat at the end again, but the takeaway is that the pH is going to be based on the concentration of hydronium ion from the stronger acid. And that will be a just fine approximation of the actual pH of the solution. So let's look at this in more detail, because this is really going to bring us back to Le Chatelier's principle with equilibrium. So for a mixture of, let's say, a strong and a weak acid, when we bring those two together, that strong acid is going to completely ionize. So let's consider this equation down here at the bottom as what's happening with our weak acid dissociation right here. Weak acid. So in our mixture, we already have a lot of H3O plus from our strong acid. So this has a higher concentration, right? So the H3O plus from our strong acid increases this. And so that increase of that product is actually going to shift equilibrium towards the reactants. So it shifts to the left. And so that means for our weak acid, which already was going to favor our reactants and not produce that many of our products, it's going to now favor our reactants even more. And so the contribution from the weak acid becomes insignificant. So that's if we have a strong acid and a weak acid. But what if we have two weak acids? Well, in the case where we have two weak acids, we can actually generally approximate that the behavior will be the same. That we really only need to consider the stronger of the two weak acids, because the H3O plus that's produced by the stronger will shift the equilibrium to the left and favor reactants even more for your weaker of the two weak acids. And so typically what we can do is, while it isn't as close of an approximation, is approximate that with two weak acids, just take the pH based on the stronger of the two acids. If the two weak acids have extremely similar Kas, then this problem gets a lot more complicated. And we'll save that for another class.